Hello friends, in this lecture we will discuss about authentication, access controls and authorization of system resources. Now, authentication is a process of confirming the legitimacy of an entity, source of a document or both. One can find a vast range of applications that demand authentication security property, starting from telecommunication, e-commerce up to border security. Types of authentication can be seen in the slide. Depending on application, the level of checking the legitimacy varies, that is, from single factor authentication to multi-factor. For example, desktop login uses single factor, for example password, whereas ATM cash withdrawal uses two factors, for example debit card and a PIN. Access control means the prevention of unauthorized use of a resource, including the prevention of use of a resource in an unauthorized manner. A function to control which active subject have access to which passive object with some specific access operation. And here subject means an active entity that requests access to an object or the data in an object, and object means a passive entity that contains the information. Controls denote the security features that control how users and systems communicate and interact with each other. Now, what are the access parameters? They are read, which is represented by the symbol R, write represented by W and execute represented by X. You may remember these access parameter symbols, which we shall be using henceforth. Once access control logic is satisfied, the subject is authorized to access objects of the system. A structure known as access control matrix, which we shall be calling ACM henceforth, is typically used for controlling access between subjects and objects. ACM contains all the relevant information on which the authorization decisions can be made. So, let us take a look at this ACM table. It can be seen that Bob has read execute access to system file, read access to accounts data and no access to insurance data. Ria has read and execute access to system file and read and write access to insurance data. Two fundamental concepts used for checking the authorization are access control lists, in short we call it ACLs, and capabilities, that is C lists. Access control list is a table that tells a computer system which access rights each subject, for example user, has to an object, for example a file. Capability is a token, a ticket or a key that gives the subject permission to access an object in a computer system. The ACL corresponding to the mentioned ACM pertaining to insurance data is: for insurance data, subjects or users Alice, John and Ria have permission to read and write, whereas for Bob it is not defined. Similarly, Alice's C list is that which shows the capability a user has, like Alice can read and execute the programs, read only account data and read and write insurance data. If we look at the use of ACL versus C lists, the concepts look similar, but they provide different ways of storing the same information. For example, ACL can attempt to name any object in the system. ACL is based on users, whereas capabilities can only name those objects for which a capability is held. So, capabilities are based on process and procedure. Let us take an example. Alice wishes to keep all of her valuables in a safe deposit locker in a bank. She has got consent of the bank that she may delegate a few of her friends to access the locker. Now, the bank can adopt two ways to control access to Alice's locker. The first way is the ACL approach. The bank maintains a list of people who are friends of Alice, authorized to access the locker, and the bank must store the list and verify the users. A friend cannot extend his or her privilege to someone else. Alice can remove her friend from the list anytime. And the second method is the capabilities approach. Under this, the bank issues Alice one key to operate the locker. A friend can extend his or her privilege to someone else, and Alice can ask for the key back from her friend. The most widely used access control notion surrounds with mandatory access control. In short, we call it MAC, discretionary access control, in short DAC or DAC, and role based access control, that is RBAC, or a combination of all of these. Let us talk about mandatory access control or MAC. This refers to the system mechanism that controls access to an object, and an individual user cannot alter that access. For example, whether write up is allowed or read down is allowed will be decided by MAC. Importantly, if such strict access is relaxed, then what adjustment can be done with respect to the levels of both subject and object, that should be guided by MAC. The other method, that is discretionary access control DAC, refers to individual's access control mechanism that allows or denies access to an object. For example, initially the access to a file was having only read. Later, the owner of the file changed the access to the file as read, write and execute, that is RWX. Further, one can also delegate his or her access rights to another person and can also apply discretionary power for controlling access to system resources. All modern operating systems are governed by both MAC and DAC. Another practical access control model is role based access control or RABC, where a role is defined for individuals and resource sharing or controlling is done with the role. Modern enterprise systems are governed by RBAC. For example, librarian is a role that can be assigned to the designated person who can have all privileges of a librarian to access system resources. What we have seen so far are linked to one part of the system security, specifically system level security. The other part of system security can look at how malicious subjects or objects can cause harm on systems and related operations. The kinds of such system vulnerabilities are buffer overflow, infectious strings, extrusions and similar threats. In this part of the lecture, we will now focus on some basic understanding of network security. It is one of the most important topics in security, as we often use applications relying on internet, mobile communications, etc. Generally speaking, when we think about network security, it brings many things into context, namely channel security, protocol security, attackers' capability, perimeter security, and so on. For instance, when we run application on a web server, the application may take input from users, it may interact with the other server, for example, authentication server or database server. It can use third party services or it can provide services to users. Many applications can be found that follow these working principles such as online shopping, banking, utility service, to name a few. However, some common vulnerabilities surface in such applications like cross-site request forgery. In short, we call it XSRF, which is a type of malicious exploit having trust that a website in a user's browser whereby unauthorized commands are transmitted. Then there is cross-site scripting, in short XSS, a type of malicious exploit having trust that a user has for a particular website. SQL injection, broken session management can lead to session hijacking and data theft in secure storage, sensitive data stored in the clear form. And let us illustrate a scenario to show how such vulnerabilities can pose serious threats to applications. Suppose Alice is browsing a social networking page where another user, say Eve, has posted a message. Suppose also that Eve has crafted an HTML image that executes an action on Alice's bank site rather than showing an image to Alice as intended. For example, Eve says, "Hello Alice, click here for an interesting image," and then the path is shown. If Alice's bank keeps her authentication information in a cookie, and if the cookie hasn't expired, then the attempt by Alice's browser to load the image will submit the withdrawal form with her cookie, thus authorizing a transaction without Alice's approval. Context where XSRF work? Eve must target either a site that doesn't check the referrer header, that is a link or script in a page that accesses a site to which the user is known and have been authenticated. Eve must find a form submission at the target site or a URL that has side effects that does something, for example, transfer of money or password change option, etc. Eve must determine the correct values for all the forms or URL inputs, and Eve must lure the victim to a web page with malicious code while the victim is logged into the target site. While analyzing vulnerabilities on networks, transmissions, applications, it is very important to assume attackers' capabilities. Attacker capability is a matter of concern because attacker could be an insider. There have been many incidents which have come into light with powerful security breaches because of insider attacker. However, it is very challenging to detect and prevent insider attacker because employees have access to inside and have inside knowledge. On the other hand, attacker could be an outsider. Outsider attacker can attempt to attack the system, application through the hotspot, open ports of networks. Outside attacker typically gathers information about the network asset before launching any attack. Moreover, attacker could be passive who can perform only read operation, that is listen, observe the communication, but cannot manipulate the information in it. Similarly, attacker could be active who can perform read, write, execute operation, that is listen, observe, manipulate, even delay the information in communication. Now, coming to the point of different types of network, say wired or wireless, topology of network, capacity of network, one should be familiar with many attributes with respect to channel security, as there may not be any defined doors while using internet for safeguarding application from malicious traffic. However, we can put a bit more emphasis on wireless networks, which found enormous usage in applications ranging from household to military applications. Some interesting features that are supported by wireless networks are no inherent physical protection. Physical connections between devices are replaced by logical associations. Sending and receiving messages do not need physical access to the network infrastructure. Broadcast communications. Wireless usually means radio, a broadcast. Transmissions can be overheard by anyone within a range, and the concerns here are eavesdropping, injecting bogus messages into the network, replaying previously recorded messages, or denial of service. IEEE 802.11i is the standard specification widely used for security mechanism of wireless networks. Wireless fidelity or Wi-Fi, as we know, consists of three main components as defined now: station, that is client device, for example, a laptop that wants to associate to the WLAN or WLAN. The term supplicant is also used interchangeably to refer to the software running on the client that provides credentials to the authenticator. Access point, a network device, for example, access point, which authenticates client. Access point is also known as authenticator. Authentication server, this maintains information about users, credentials, and facilitates authentication for authenticator. The access point keeps broadcasting beacon based on its range, by which system equipped with wireless network card can identify the network. A connection request response can decide whether the system is allowed to access the network. The security part comes while gaining access to the network, which may be checked through one of the two widely used protocols: WEP or wired equivalent privacy, authentication, open system and shared key, authorization, MAC address filtering, confidentiality RC4, integrity CRC32. WPA or Wi-Fi protected access, authentication 802.1x, confidentiality TKIP and RSN, integrity MIC. One can classify WEP access control, you can refer to the slide here, with two broad classes: authentication, open and protected, and authorization, MAC address filtering. The protected access control follows a four-way challenge response protocol with shared key based authentication and integrity check. Number 1, client sends authentication request to access point, then access point sends back clear text challenge. Next, client encrypts challenge using shared key, and then access point decrypts and compares the response with the challenge it sent. We should note that WEP suffers from security weakness and should not be advisable for security sensitive applications, including e-commerce. One may refer to the paper for knowing more on security weakness in WEP, titled intercepting mobile communications, the insecurity of 802.11. In case of Wi-Fi protected access, that is WPA, which is more secure than WEP, there are two options, WPA and WPA2. WPA is TKIP, cryptographic checksum of message, while WPA2 is RSN/AES hyphen CCMP, and indeed WPA2 performs better than WPA. However, it is important to note that the selection, whether open, WEP, WPA or WPA2, lies on the user who uses the wireless networks. One can get the default setting, but that may not be adequate to handle the application with respect to its intended security goals. So, it is advisable to check the network setting of wireless networks once someone starts using the network and can always reconfigure as per need. With WPA or WPA2, the authentication is strong as it supports port based authentication. The authenticator becomes the intermediary for relaying EAP, that is Extensible Authentication Protocol, received in 802.1x packets to an authentication server by using RADIUS, that is Remote Access Dial-in User Service, to carry the EAP information. Here, RADIUS works with challenge response protocol between authenticator and authentication server. Finally, perimeter security is an important defense for securing enterprise network. The tasks of perimeter security are to filter network traffic as normal and abnormal by firewall and detect intrusions by intrusion detection system. The intrusion detection system or IDS can be host based IDS, which monitors single host activity, specific system based protection, whereas network based IDS monitors network traffic and monitors traffic at selected points on a network. The logical components associated with IDS by which it detects incidents are sensors, which collect data, analyzers, determine if intrusion has occurred, user interface, which manages or directs or views IDS. To summarize this entire lecture, it is important to note that having some sort of familiarity in network security helps in handling malicious intent while using various applications with a communication channel. The network security domain involves a lot of security and privacy challenges that one has to handle with care. There are many active research problems pertaining to this domain, which one may take as an exercise for further study in this domain, for example, social networking, cloud security and Internet of Things.